Hello viewers and welcome to a new video which will not be an STM32 world tutorial video but rather me fixing a bug I created in an earlier video. A while back I did a video where I implemented a bootloader and a relocated application and switched between them, and everything that was working fine. I did a somewhat naughty trick to track a variable between the bootloader and the application, so the application could signal to the bootloader on restart to run the bootloader. I need to store a flag between restarts of the processor. I later found out that I got another idea of doing this, and that was introduced in STM32 tutorial video 39, a cleaner jump to bootloader. What I did in that project was I changed the linker script slightly. Rather than what I did in the first version, I simply put in the linker script an e-stack, which is the last byte of the RAM, is defined as the top of the stack or the bottom of the stack, depending on which way you look at it. But rather than doing it that way, I decided to try to relocate the stack by 4 bytes down, and I implemented that with the application and the bootloader, and it seems to work just fine. We have it here. If I restart the MCU, that is that button, it will start counting up the ticks. If I press and hold the user button for 5 seconds, 3, 4, 5, let go, it'll go into the bootloader, and if I press again, it'll go back into the application. So it works. But actually using this myself in another project, I noticed a bug that I couldn't explain. And basically I can simulate that here by changing that tick printf to actually print out a floating point. Now, before you scream at me, I have in the properties, and where is that? That is in the settings. It is up here where you have to check that if you want to include the float. If I do it that way and print out this same tick variable but as a float, I notice something really peculiar, and that is, we try to run that. It no longer prints out the tick. Now, I must admit I noticed this about two weeks ago, but I didn't really understand what was happening, and going back to my old system by just setting that flag 100 byte from the top in the middle of the stack, that worked fine. So it was one of those things that just in my head got parked in to maybe have a look at later. But then a couple of days ago, somebody commented on my YouTube channel, and that was actually very, very interesting. I wouldn't say I fully understand what is happening, but the comment was from a guy called Daniel Nystrom. Sounds Swedish. Hello there, Swedish friend. I'm Danish, by the way, in case anybody didn't know that. It says that the ARM EAB requires that the stack pointer is 8-bind aligned, and he came up with a solution, and lo and behold, he is absolutely right. That is all that is required to fix it. Instead of moving that stack 4 byte, if I move it 8 byte, let's try that out. Let's do the where have we got the bootloader first? So let's look at the bootloader linker script. So if we move this 8 bytes, build and run, there. Now it will still not work because I haven't updated my my application. This was just the bootloader. but the bootloader and the application need to agree on where that flag is. So if I now go in and look at the linker script from the application and do the same change there, oops, and try to run it, now all of a sudden, lo and behold, printf works and the loop counter is back to working again. I mean, it is just counting up 1, 2, 3 like it did before, but it will actually show the value and the loop counter is correct as well. So there you go. The stack has to be 8-byte aligned. I wouldn't say I exactly understand why this is the case, but it's apparently a requirement from a lot of the ARM pre-compiled libraries, standard libraries require this. And I mean, who am I to argue with the wizards who created that in the first place? I don't think I'll ever really figure out what's happening there. It's not important enough, but it was an interesting observation, and I managed to fix a problem I did in an earlier video, and that is always good. And I will probably use this approach. I would say my original approach, if you go back and where do we have it here? If we look at the videos, what video number was that? Videos, custom bootloader, I think it was called. Well, cleanup jump, it must be before that. Am I blind? Wait. What did I call that video? Understanding, creating, custom. Oh, it's here. So it was in 40. I actually created the original project, and yeah. So have a look at that video, and the approach I introduced in this video was simply, it was a bit naughty, putting a variable in the middle of the stack. Well, have a look at that. It is also, by the way, described on the STM32 world video. Jump to bootloader. I think it's here on the wiki. STM32 jump to bootloader, and there is even a revisited I will have to then have a look at. Jump to system memory bootloader. It described a slightly naughty approach, and in that naughty approach I simply put a flag in the middle of the stack. So I don't change the original linker script, but I set a variable with a bootloader offset down in the stack, and just 100 byte or something like that. It will ruin the stack, but since we are ruining it here, and then immediately, here, we set the bootloader flag. That's the only time we write to it, and then we reset the MCU, in which case the stack will be completely started all over again, so it doesn't really matter. So this approach works, the one I've been using this for a while, but the new approach will also work, but it wastes 8-byte of memory rather than 4-byte as I thought. So that's about it. I will not put this as a number tutorial, but just upload it as a fix. And that is it. Thank you very much, Daniel Nyström was his name, right? Much appreciated. I love getting comments like that because it really helps. It really helps, and it's also always nice to get response. As usual, have a wonderful rest of the day.